Welcome back to Nolacule. Today we're diving into a story about a really weird trick that blew the doors open for AI. It all started with a crazy discovery, and AI actually got better at translating sentences when you fed them in backwards. Yeah, you heard that right. This bizarre little finding led researchers on a quest to solve a massive problem. How in the world do you teach an AI to think outside of a nice, neat list?
I know it sounds completely backwards, right? I mean, you'd think that scrambling information would make things harder for a machine, not easier. But this one single strange result was actually a massive clue. It pointed to a much bigger challenge in AI, one that a team at Google Brain decided to tackle head-on.
Okay, so here's the heart of the problem. AIs, especially the older ones, are basically built to love sequences. Think about it like a recipe. Step 1, chop the onions. Step 2, heat the oil. The order is absolutely everything. But the real world, it's not a recipe. It's way more like a random bag of groceries, just a jumbled, unordered collection of stuff. In computer science, they call this a set. So the big question was, how do you get an AI that's obsessed with recipes to make any sense of a messy bag of groceries?
Well, the old way of doing things was pretty simple. Just force the jumble into a line. The AI would look at item number 1, then item number 2, then number 3, and so on. Just this strict one-at-a-time process. This is what we call a sequence-to-sequence model, and it's basically designed to turn one ordered list into another ordered list. It's powerful for sure, but it has this huge built-in assumption that the order you give it the information is the only right way to look at it.
But here's the bombshell from the research paper. The researchers realized that even when you have a jumbled mess of items, some ways of looking at that mess are just better than others. The crucial point is, maybe the AI wasn't struggling because the data was a jumble, but because we were forcing it to look at that jumble in a really awkward, unhelpful order.
And this realization completely changed the game. The goal shifted. It wasn't about trying to build an AI that was somehow immune to order. No, it was about creating an AI that was smart enough to find the most helpful order all by itself. This one insight led to two major breakthroughs. So first up, they had to invent a totally new way for the AI to even see information. Forget looking at things one by one. They needed to give the AI a kind of superpower, the ability to see the whole entire picture all at once.
They call this superpower an attention mechanism, and it's actually a beautiful concept. Think about it. When you walk into a room, you don't scan it like a computer, pixel by pixel from left to right. Your eyes instantly take in the whole scene and just dart to the most important things: a person's face, a bright light, something moving. An attention mechanism gives an AI that exact same ability, but for data.
This new ability became the heart of their new model, which they called read, process, write. So step 1 is read. Instead of that slow, one-by-one plotting, the AI takes in the entire set of jumbled items in a single, simultaneous glance. Everything is on the table right from the get-go.
Then comes step 2, process. And this is where the magic really happens. The AI uses its brand new attention ability to just think. It looks over all the items it just read, it considers how they relate to each other, and it decides which ones are the most important for solving the problem. It does this over and over for a few cycles, getting a better and better sense of the whole picture.
And finally, we get to step 3, write. After it has fully processed all that information, understanding the whole set instead of just a sequence, it starts to output the answer. It's now giving a solution that's based on a complete, holistic understanding, not just on the last thing it happened to see. So, the big question, did it work? Well, the researchers put it to the test by asking both models to sort a jumbled list of numbers. On a simple list of 5 numbers, yeah, the new AI was a little better, but check out what happens when the list gets longer. With 10 numbers, the old AI completely falls apart. Its accuracy just plummets to 28%. The new AI with its supersight, still going strong at 57%. This was a huge deal. It proved that this new way of seeing the data made it way, way better at handling complex problems.
Okay, so the AI can now read a jumble. That's awesome. But what happens when the answer you're looking for is also a jumble? This led to the second big innovation, teaching the AI how to talk, or how to output information when there's no single correct order for the answer.
Imagine you have to describe a painting. If I force you to describe it strictly from left to right, you'd end up with a really weird, totally unnatural description. You'd much rather start with the main subject, then talk about the background, then maybe a cool detail in the corner. The researchers realized they were basically forcing their AIs to describe paintings from left to right, and that aha moment was realizing they should just let the AI find the order that tells the best story.
So they came up with this incredibly elegant solution. During training, instead of telling the AI, nope, this is the one and only correct order for the answer, they just let it try out different orders. And whenever the AI stumbled upon an order that made the problem easier for its own internal logic to solve, they rewarded it for that. It literally learns to find its own path of least resistance.
And the results were just stunning. They tested this by giving the AI a jumbled phrase of 5 words and asked it to predict the next word. When they forced the AI to process the words in some awkward random order, its error rate was pretty high. But when they let the AI choose the best order for itself, out of all 120 possibilities, it learned to pick the most natural, human-like order every single time, getting the lowest possible error rate. It literally found the best story all on its own.
So why does any of this matter? Look, this wasn't just some small tweak. This discovery fundamentally changed how we build AI. It meant we could finally start pointing our AIs at the messy, jumbled problems that we see in the real world. That attention mechanism became a cornerstone of modern AI. It's what led to the powerful language models we have today. And it showed us that maybe the best way to build intelligent systems isn't to force them down some rigid path, but to give them the flexibility to find their own solutions.
Which leaves us with a really fascinating final thought. This research basically taught an AI a kind of intuition, that gut feeling for how to best approach a problem. If we can do that, what's next? What other subtle human ways of thinking can we design systems to discover all on their own? The list might be a lot longer than we think.